All right, good morning. It's 11 o'clock. Our first presenter for this series is Dr. Jerry Sellers. He's the author of Understanding Space, An Introduction to Astronautics, a contributing author and editor of Applied Space Systems Engineering, and a contributing author of Human Spaceflight Analysis and Design. He has over 40 years of space systems experience, including guidance and onboard navigation, officer in Space Shuttle Mission Control, assistant professor of astronautics at the U.S. Air Force Academy, and chief of astronautics for the Air Force European Office of Aerospace R&D. He is an associate fellow at AIAA and the former chairman of the Space Systems Technical Committee. Jerry is a certified Scale Agile program consultant and a corresponding member of the International Academy of Astronautics. He is also an adjunct professor at Stevens Institute of Technology. Please welcome Jerry.
All right, thanks, Dave. Good morning. How's everybody doing? A lot of AI discussion yesterday, so we're going to continue the AI theme here. So I think I might have mentioned with other talks the other day, but there's a project we've been using for going on 30 years now called FireSat, and so we always call it the most famous mission that never flew. And the idea is a satellite that detects wildfires. Okay, it's pretty benign. Everybody, kind of motherhood. Everybody thinks it's a good idea, and it's kind of a neat, cool kind of a project because it's just complicated enough that you can flesh out a lot of the important details that you see in any project from a system engineering or project management standpoint, but not so complicated that your brain explodes, right? So it's not like the space shuttle. Oh my God! So we've been using it for a lot of examples. So I'm kind of wearing my Stevens adjunct hat here today. One of the things we do at Stevens is students in the system engineering program get to do an independent study. So it's not a thesis, kind of a mini thesis, but it's a one semester independent study. And then I get to come up with a project for them and off they go. So that's what we're going to be reporting on is using FireSat, and we have a new version of FireSat we've been working on. In fact, I gave a talk on it last year at the conference. We're kind of doing a reinvention of FireSat. The original goes back to like 1990, Space Mission Analysis and Design textbook. We're doing a reimagining of it and a digital version of it, if you will. So we're actually doing phase A, phase B, phase C. What I reported on last year is we got through pre-phase A. So we actually did our initial set of requirements, and now we're going to phase A. So we're trying to flesh out our kind of baseline set of requirements, and then we're going to move on to phase B and C and actually go through and do the system design, and eventually we'll actually look at come down to component level selection to see what the sizing is and mass and power and all that from a more hardcore engineering standpoint. But we're building a system model for the whole thing. So I've been using Inslate to build the whole thing and requirements and architecture and everything. And then we'll probably build a twin of that in Cameo in parallel here as we go along. So that's kind of the background of what we've been doing. So I'm my author along with my two co-authors, Amanda, who's wandering around the conference here too, and then Marwan Mousley is my grad student. So this is that's his last class. So he gets to graduate next month. If I pass him on this course, he gets to graduate. So he's sweating it out. I said, well, we'll see how it goes here. So you can read that there. I apologize to the organizers, but I gave the template to Marwan. I said, hey, can you put the slides together and follow the template? And he said, well, can I take a bit of artistic license? I said, well, yeah, I guess so. And he kind of went crazy with it. So there's a lot of fun AI generated stuff he did in here just because he wanted to. So again, the background here is that we're using FireSat Nova as our kind of example. And then with the real question we were trying to ask is, could we use generative AI to help us write requirements? So being creative and writing requirements and see how different platforms would perform on that. And so basically test them out and then compare them to see how well they were able to do that. So we're trying to get them to take our high level requirements and turn them into lower level requirements. And so and requirements and quote good requirements. So I'll talk to you about what we mean by good requirements here in a second. So, and we want them to align with the mission objectives and with kind of regular engineering standards. From background, so this is, we're not claiming this is the first time anybody's done this. Some of you have been talking about here this week. This is just a subset of the literature review that Marwan did. It's first thing you teach in this class is you go do your literature review and make sure you're not duplicating somebody else's work. So there's been a number of activities out there, people trying to do this. So this is not necessarily a new idea, but I think our twist here is that we had a very specific set of problems we were trying to solve, and very focused on space system engineering in that application. So the approach here is to say, okay, well, we're going to use commercial AI tools, and we used ChatGPT 3.5, the Mini 4.0 and 4 Turbo, and then Grok. And then you'll see later we used also 4.5, but that was actually kind of phase 2 in a way. And we wanted to see how well they would work. And so one of the questions, of course, is how do you compare? Right? How do I compare apples to apples here in terms of the quality of the requirements that are getting generated? And so what we did is we turned to Innoslate. Innoslate has a quality score capability built into it. So you can give Innoslate, for those who aren't familiar, if you put in your requirements and you hit quality check, they have a natural language AI already built in that reads a requirement and gives you feedback on 9 quality score metrics, which are based on the NCOSE metrics. So feasibility and verifiability and all that. And so it gives you feedback on that pretty much like that. So that that way it was consistent, and you could argue whether it's good or bad, but at least it's consistent. And so what we wanted to do is, as we're comparing the performance of each of these AIs, we could then always use the Innoslate as the objective arbitrator of goodness of the requirements that came out. And again, that quality score is actually really good in terms of picking out things like, if you use the word all or never, or you don't use shall, if you have a comma, if you have an and, it's very good at sort of, I might say, grammatical issues that come up in requirements. It'll actually try to flag things that look like one requirement looks like another, and therefore it might be a duplicate. But it's still an AI, and if I say I want to build it out of unobtainium, it's fine as long as I'm consistent with unobtainium, right? So it doesn't know whether feasibility is something it leaves to the user. So of the 9 attributes, it doesn't automatically score all of them. It only scores about, I want to say 6 or 8 of the 6 or 7 of them, and the rest just leaves to the user to say whether it does it or not. Verifiability is another one which we did not do, because for verifiability you have to show that the requirements trace to some verification activity, which we didn't bother to do. So of the attributes, we didn't try to achieve, we weren't even expecting to achieve 100%, but for the ones that were that it could score, that's what we looked at. So part of this, and those of you who've worked with AI, I always like to compare AI to a really smart, really motivated, really ignorant intern, and who's also very patient. And if you're patient and you keep working with the AI, it usually gets better and better. Not always, right? So the more, and so a lot of the more training you put in up front, the more likely you're going to get a good product. So we wrote a pretty detailed script, and I don't copy of. I can get you a copy of it if you're interested. It was too long to put on the slide, but we put a really detailed script that set the persona, and we gave the AI in each case, whichever AI we used, we gave it the level 1 requirements, the level 2 requirements, the level 3 requirements, which we did previously, and those were human generated, human vetted. They're actually, I would say, a reasonably good set of requirements for at that level. So if those of you familiar with A spec, B spec, C spec, anybody know what I'm talking about? So that's what we have. We've got A spec, B spec, C spec, and now we're going down to the D spec, which is a subsystem requirements. So part of the training was, here are the level 1, level 2, level 3 requirements. And actually, because we had the functional model, here is the functional model, the behavior, the things that the system performs, and the input outputs. We said, so it gave it that as 4 files, and then gave it some very specific directions about what to do and not to do in terms of what the expected, how it was going to be scored when it went into the quality score. So all that was bundled in, and then we said, okay, now let's pick a subsystem. So we picked electrical power. So why not? We can pick any subsystem. So let's start with electrical power. So we want you to write requirements for the electrical power subsystem. So this would be, in my terms, a set of level 4 requirements, right? That flow down from 1, 2, and 3, right? So that was the backdrop. So then we built that script, and then we then use the various AIs to see how it would go, right? And then we would iterate a couple of times depending on the AI to see if it could get any better. So we set up here, this though you're familiar, this is an eye by eye matrix. So this kind of tells our process. So we laid this out to show what our process is for how we would do that. We did not share this with the AI because it didn't know how to read that, but that was for our understanding, so we could understand the process, the input output. So if you're used to these, you read them clockwise: output, input, output, input. That showed how we could actually the flow, the data flow here for what we were doing. And so when you generate your requirements, then, and this is our first go with the tool. This is using 03 ChatGPT 3.503 mini. We gave it the script. We said, okay, go for it, and it created the requirements. And these are the requirements. Then it spit it out. We'd have to tell it, hey, please spit it out as an Excel file or CSV file. Installate's really good at ingesting that. As long as it's in the right format, it just comes in like that. And then all we have to do is push a button, and we get the quality score. And I don't know if there's a laser here anywhere. Is there a laser? Let's see. Is there a pointer here? Sure. Okay. Well, if you look up there, you see the little bars there, yellow and red. That's the quality score. And if you then were to click on any of those requirements, it'll tell you the attributes based on that quality score, and it'll even give you feedback. So if it's red there, it may be because there was an and or a comma or a parentheses or an acronym or something that it kind of flagged to say, hey, here's a problem. So that if you've not used a quality score in Inslate, it's a pretty cool capability, especially if you've got dozens or hundreds of requirements and you get feedback like that, which would take humans forever to do, and then you can go zero in and say, hey, why is that red, and then try to fix your requirements. So then this gave us an overall quality score, and then we tabulated that. So, you can see some are 32%, some are 50%, whatever. So then we tabulated that to come up with an actual score. So the first iteration, and you can see in this one, came out at a 38%. And then we took fed back some of the issues that were flagged, and you notice the score went up. And then we fed back some more issues, and the score went up. So it went from like the 38 up to about a 42 for this particular large language model. Then we went to GPT 4.0, and here again, it's the very same process. We gave it the same script, and we evolved the script as we went, because we would learn things that, hey, maybe we need to tell it this. Hey, maybe we need to tell it that. So when we did the iteration, so when we ended the iteration on the last go, that was the script we used for the next one, if you will. So then here you can see that the scores actually started out pretty good, and as good as the other one, and we got no improvement on the second iteration, even though we tried to fix some stuff. And then look what happened on the third iteration. It got worse. It forgot to put shall in this requirements. Right? Well, temporary insanity. So we say, hey, shall, and then it went back, and it still didn't get as good as it did. So and again, and we're trying to be as, design of experiments as we can and being consistent about what we're doing. But there were still differences you can see. Then we went to GPT-4 Turbo. We only did 2 iterations with that before it kind of leveled out. It was not as good. In fact, which was weird because in my grad students' research, people had suggested that Turbo would be better for requirements, but it turned out not to be the case. It was just not as good. So it did not score as well as the other. And then finally, we went to Grok, which I really had not had any experience with. I don't know if anybody here had, but Grok actually did pretty well right out of the box, but did not really get any better. Our secret suspicion that folks at SpaceX are using it for Starlink, so they somehow already knew how to do subsystem requirements, because it actually had some requirements that were pretty insightful compared to the other models. But the scores overall were not necessarily much better. But it kind of got us a better, initially better, but then really did not improve much beyond that. And then, so this is just some graphs here to show what the various tools do, and so you kind of see where they level out and how you see Grok and GPT 4o roughly the same in terms of overall quality. So then we said, all right, well, we could kind of keep doing this in different models, but let's try a different tack. Let's just let's try something else. So we said, well, let's take the Grok requirements and we'll give so we kind of departed from our old process. Let's take the Grok requirements and we're going to feed that into GPT 4.5 and see what it does with it. And said, hey, see, can you improve upon this? And it took it in, but it actually didn't improve on it much. So it was like a 2% improvement, which is not a big deal. So it helped to seed it with a better set of requirements, but it did not make a massive difference, which again you might have suspected that it would. So here you can see the comparisons there again, even after we did the other one, with 4.5 now put in there. So 4.5, after being seeded with the Grok requirements, was the winner, if you will. But again, it took a lot of iterations to get there. So what did we learn? So I think going forward, I think it's, if there's something we learned that we take away, is that using the quality score from InnoSlate is I think a reasonably good objective way to compare apples to apples if you're trying to really compare requirements. Because a human doing that, I don't know how that'd be way too hard, because it just took minutes to get the score there. Surprisingly big differences between the AI platforms. I would not have expected to see that, and so and I don't know the reason for that, but that was what we saw. And I think kind of stating the obvious, the more explicit the directions, the better the product. But even then, from iteration to iteration, it would forget things. So even though here are your written instructions, it would forget them, and that's scary and annoying. So I think my overall impression here is that we're not quite there yet in AI generated requirements. Maybe we'll get there, but we're not there yet. That being said, I read people's requirements all over the industry, and they're not much worse than what most engineers are currently writing, let me tell you. So they're not up to my academic standard, but compared to what industry folks are doing, like, yeah, okay, it's no worse than engineers. So maybe we can replace engineers with AI. I don't know. So what are we going to do next? And we had to put pencils down so we could get this presentation out, but Marwan's going to publish his paper, and so if anybody's interested in a copy of the paper, which will be out here in the next couple of weeks, I'm happy to share that with you. And if we get time, we're going to see how we have how much time we have in the next few weeks, because he's got to have pencils down in about 2 or 3 weeks. Then I think our next approach will be to create a proof set of subsystem requirements. So again, roll in a SME, which will probably be me, to write, okay, here is a definitive set of electrical power subsystem requirements. Use that as the seed to write, let's say, communication subsystem requirements or attitude control requirements, and say, all right, whichever model, here's all that background, here's all the level 1, level 2, level 3, here's the functions, here's an example set of what we're looking for. Can you go write now, comm system, propulsion system, subsystem, and see what happens, and see if that helps. Because to me, at the end of the day, why are we doing this, right? We want to save time and effort. At some point, I have to come up with subsystem requirements for all of my subsystems. There's like, what, 12 subsystems, depending how you divide things. That's a hell of a lot of work. If I can get AI to do a big chunk of that heavy lifting, that would save me time. But if all I end up doing is rewriting everything it did, I might as well just write it in the first place. So I'm trying to see if there's actually some value. And of course, what we're trying to do in this whole project, big picture, is we want a so-called digital twin. My joke now is I can't get funding to build a model, but I can get funding to build a digital twin. So so I tell everybody I'm building a digital twin. But we're trying to come up with the FireSat Nova as here's an example, an exemplar MBSE model of a space mission. And I've actually been using it already for people like, how do I write requirements? Well, here's an example how to write requirements. How do I do the functional architecture? Well, here's an example. So trying to give people examples, because it's always easier to work from, copy than invent, right? So that's kind of where we're going to try to see where we go next. And if anybody's super interested and wants to get involved, we're always looking for reviewers. So I actually had some folks from the last MBSE-CON that helped review when we did the pre-phase A mission concept review. So coming up, we're going to do a system requirements for you. So if anybody really likes reading requirements, I got some fun for you if that's what you want to do. Let's see what else we got. Oh, there's his references, because it's an academic paper, so he had to put all his references in there. And that's it. Thank you. So I need the box. Does she need the box, or she's?
Oh, yeah, where's the box?
Oh, there's.
My question is, when you were looking at the highest results you got of that 49% improvement, did you go back and then look at some of those ones that were marked red to see if you could figure out reasons why?
Oh, yeah.
I couldn't improve them? What did you find?
In some cases, remember I said it's never going to get 100%, because some of those require a human to say, yeah, it's feasible, or yeah, it's verifiable, and we just didn't bother doing that. So we just we had to just stop at the ones, to try to get apples to apples. So it always stopped at the same place. And in real life, if I got to the point where I was happy with those, then I would go in and manually flip the switch and say, yeah, that's feasible, or yeah, that's verifiable. If the things that require a human to ascertain. But that's kind of how that tool's set up, because it doesn't try to pretend it knows it's feasible. But even if just even getting that far helps you really vet down, skinny down, filter down to the most heinous requirements that you got. Right? So yeah.
So you might have already touched on this a little bit, but for your SME approved sets, I was wondering if you tried using like a custom or anything like that, or if it's just going through like the general sort of chat. But I believe in if you make a custom GPT, you're able to actually like give it documents things to retain in its memory. Otherwise, like a general GPT, I think eventually forgets that kind of thing. So I was just kind of wondering if you have tried that yet, or if that's.
No, I mean, the ones we use were paid. Well, in some cases, paid subscriptions. So it's supposed to have memory turned on. So it should have done that, and it accepted the documents and theoretically read the documents. So that shouldn't have been a problem. But we have not. Again, there's as you guys have talked this week, so I mean, there's all sorts of different there's zillions of options out there at this point, right? So we just said, let's try the ones that are most commercially available that average person might be able to grab onto. But yeah, and this field is, as my son tells me, AI is as bad as it will ever be right now, right? And so it's moving target. So it's going forward, well, let's try to see how do we experiment with those tools. And some of the things you guys have been doing at ManTech, where you're trying to come up with your own kind of building your own AI agents. I mean, that sounds like the future to me. Basically, it's like you have Joe over here is our requirements guy. You're like, okay, now we have AI Joe over here is our new requirements guy who's trained to do that, right? So that sounds like the right answer in the long run. But part of this is understanding what is good to even look like, and how do you train that? So I think that process is still important.
So you haven't given it any example, like that the next steps was let's feed it some good spec and I haven't used that as an example. You haven't done that?
Haven't done that yet. Yeah.
Will that part be included in the paper, or will that be a follow on?
We'll find out how much time we have in the next couple of weeks. So that's my.
You can giving it an example of something you want to do. It normally, again, I'm doing normally just textbook stuff, but normally I feel like it gives me a lot way better.
Well, we thought by giving it level 1, level 2, level 3, that it could then extrapolate, but it did as well as we might thought.
And second question, when you fed in the grok results back to GPT-4, did you also feed those results back in like what was wrong, or at least like the percentage of each requirement? So
no,
it didn't know which ones.
It did not know. Yeah, we just I'm trying to remember if we changed the instructions. We might have added another instruction. I'd have to go back and look, because there's things you don't think to tell it. Like, oh, by the way, don't use and or. You're like, oh yeah. Oh, by the way, don't put a comma. Don't use words like all. Things that it's like anything. Don't assume, right? And so you learn that you got to be extremely explicit. So in a way, you kind of generate a how-to guide for anybody to go write requirements that way, right? But again, it's something, I always joke that how many of you as an undergraduate engineer took a class on writing requirements? Yeah, you as an undergrad, were you a system engineering?
Yeah.
Okay, well that's okay. Undergraduate aerospace or other engineer, like no. Right. And the joke is we don't want undergrads to know about requirements because they'll stop being engineers. So they find out about it in the job. Like, yeah, I got to do what? So anyway, other questions? Got 3 minutes. All right. Well, thanks.
Maybe.
You just stop sharing and reshare to get the audio on the video that comes at the end of the. In today's complex, sold.
Okay, so that's that. It's going to be next to the tab here, right? And then you have John's presentation.
Yes, Jerry.
Oh. Okay, so just tab out right here. Okay.
Sorry, tab on.
No, I mean, John can do it too.
Okay.
So
Yeah, good.
yeah, I mean, just tab out of your presentation and just go in the media player.
I got you.
Pretty simple. Okay.
Good. 2 minutes. Oh.
No, I'm gonna expose you all to that.
Came all the way down.
What do you call a beehive with no exits? Unbelievable.
Are you proud of that? Absolutely.
My son told me the other day that if I'm ever attacked by a car full of killer clowns, always go for the juggler. Thank you. Whoever booed, that's the door. Yeah.
Bad jokes.
See, jugular looks like jugular, and so it's a combination of, it's really bad when you.
You just get funnier when they explain them.
Billy had to explain the B one too. I didn't get it.
All right, it's 11:30. Our next speaker is John Gibbs. His 30-year career bridging military service, thank you for your service, and civilian roles has provided a comprehensive foundation in both digital and systems engineering principles, supported by master's certificates in engineering of complex systems from the Massachusetts Institute of Technology, model-based systems engineering from Purdue, and a bachelor's degree from the University of Idaho. John's military experience as both a pilot and a plank owner of the Naval Space Cadre instilled a rigorous approach to problem solving, emphasizing the importance of systems-level thinking, requirements management, and the integration of complex technologies. John is currently exploring the integration of artificial intelligence to enhance mission engineering capabilities. This unique combination of disciplined military technology, advanced academic credentials, and a focus on leveraging AI for mission advantage enables him to effectively tackle intricate engineering challenges and drive innovation in developing and deploying complex DoD systems. Please welcome John.
Thank you very much. I appreciate it. Well, as you said, my name's John Gibb. That was a great intro. Thanks, Gemini, to help me generate that. Made me sound absolutely awesome. What I want to get into in the next 20 minutes is really a use case with AI. And when we talk about artificial intelligence, and we've seen lots of different ways to actually grab a tool and apply it in different ways, this actually is almost a briefing that would be good for a lot of us to take back to our customers. Because the way I'm using AI here for this audience is not revolutionary by any stretch of the imagination. But a lot of folks you'll find that you interact with daily are the folks that understand what AI is, but they don't understand how to apply it. So this is a use case that kind of takes folks by the hands to say, try this and see how well it works. So jump to the next slide. That's me. We already covered that. So, all right, what's the purpose of this? It's really to show that AI is both accessible and applicable to what you're doing on a day-to-day basis. And, you can't swing a dead cat without talking about artificial intelligence and how you would do it. So I imagine that everybody's heard it a whole lot, set aside this conference, recently. And also your perspective has changed as far as how it's applicable to you. So, there really is no avoiding it. AI is happening, the future is now, and it will impact your life. But what you do get a chance to say is, how will it impact your life? And what I've found a lot is that there's two basic perspectives as we get into artificial intelligence. And number one is it's too complex, it's going to take my job, and I'd rather be an ostrich and stick my head in the sand. So part of what we need to do on a day-to-day basis is to realize that the end of the world is not coming. It's not Terminator. But you also have the folks that are just so exuberant and want to do everything with AI, and it's going to change everything we do, and this is awesome. I'm trying to help folks find that middle ground, right? AI is incredible. The technology and what we've been able to do really in the past 6 months with AI versus the past 18 months that we've done without it is incredible. So the technology is good, but those two perspectives, we got to play in this space, that middle ground. Where it's understand its strengths and what it can do. And we've seen a lot of great use cases on the strengths of what it can do. What we also have to do is understand it with guarded optimism. What can't it do particularly well? All right. So the good news is I don't think AI is going to take anybody's job, especially not in this group. But people who know how to apply it, make it a run for your money. Because it is a tool and it is going to be transformational. So how do you use it? And this is just a simple, approachable use case that we used with a digital thread. So let's look at it with mission engineering. Step back and talk a little bit about what is mission engineering. So it's mission first, right? It's always starting with that capability gap. What can't we do currently? And if we look at our current and future programmed acquisitions, are we still going to be able to solve the identified gap? So it's also making sure that you have the solid metrics, the solid data behind it to solidify exactly what it is you're talking about. In order to do that, if you really want to go from the depths of engineering to the intricacies of what's happening in a foxhole, you have to have a lot of expertise to bridge that gap. And so the list there is all the different experts, and building a team like that in one environment, probably not all that feasible because all of those people are all busy, all doing different things. So building a team like that is hard to find. And the former chairman of the Joint Chiefs of Staff was quoted as saying, you know, we have to accelerate or we're going to lose. So we don't have the luxury of time right now. So artificial intelligence and mission engineering is the focus that we're headed towards. And so this is a little bit of a simple use case on how to apply it. So looking at the multi-step process, it's actually 5 steps, but my little wagon wheel there that showed the steps that we walked through in the digital thread has 7. So that's why there's 7 up there. But really what I want to talk about more so than the number of steps is looking at the first one, right? You have to know the problem that you're solving before you even get off the ground. Understanding what the problem is, and not necessarily that somebody says, hey, I need a widget. Okay, what's the problem you're trying to solve to get to that widget? And this is fundamental to any engineering problem, but you'd be shocked at how many times, and I have a common case of one example that I normally think of was, I was in the Air Operations Center in IUD, and I had a friend of mine who was working in the Joint Rescue Coordination Center who came up to me and said, I need a Predator over this point right here, right now. Okay, why? You really don't need a Predator. In the heat of a rescue is not the time to talk about that. You don't need a Predator. What is it that you need? I need full motion video, and I need a near real-time relay so that I can see what's happening on the ground right now. Okay, there's lots of other systems out there that can give you what you truly need and fix your problem that aren't a Predator. So let's ask the questions, right? Asking those questions, and with AI, we all know query is the king. You have to ask that right question. The other piece about it is that data that you're going to get back and the data that you're going to feed the AI. I just threw in there that that's the queen, because you have to build the right AI partner to make sure that the information you have is authoritative and true. And you also have to have some expertise to review it to make sure that that information stays accurate and, again, is authoritative. So building your AI partner, this is within AI Gemini, or Google Gemini. And what areas do you need to have your AI be an expert in? And so where I was focused in this particular case was looking at both doctrine, excuse me, I'll walk up here and grab my water as I'm talking. Looking at doctrine, both joint doctrine from JSIDs, even though it's going away or it's being heavily modified, we still need to use it. Also Marine Corps doctrine, the Marine Corps acquisition guide is a key component to that. And then also theater analysis, what's happening in the world right now, and strategically, where are we going? What problems do we need to solve? And then the mission engineering guide put out by the Assistant Secretary of Defense is out there, and that kind of walks you through all the different measures and how you link the most detailed requirement back up to the problem that you're really trying to fix. Okay, and so then once you have the initial problem that you're starting to look at, you have to start bringing the mission into it. And that's where you start looking at it from a strategic level. And I have in there global strike versus anti-access aerial denial, or A2AD. So, U.S., it's not a secret at all. U.S. has long had the vision that being where we are geographically, the ability to project power, global strike. The United States has the power and the wherewithal to strike anywhere in the world within an hour, matter of hours, both conventionally and unconventionally. So that's a tremendous capability. So adversaries have been looking at that over time and start looking at, okay, how do we do that? And how can we keep you outside of the weapons engagement zone so that you can't get to an area where you can strike? That's A2AD, right? So where are you in the world? What's the environment that you have? And also politically, what's happening in that world, which will allow you to operate. The other piece is there's going to be a lot of assumptions anytime you start getting down into a mission thread. And when you do that, That's great. Assumptions are key to what we do. We just have to define what they are and put those up front. And in this particular piece, as we walk through the kill chain, which are the steps that you see over in the bubbles on the left, my left, we have to build a command and control picture. Right, those are the first two steps in the find and fix. You have to know what's out there in the common operational environment. Okay. So the other piece is defining it consistently, right? Defining it using the common terms within joint and service doctrine. That is your authoritative source of truth, so that we're all using the same language. You know this better than anyone with your work with CJETC too, Kevin. But that common lingo has to be adopted and used. Because if I start using the term puppies, you start using small dogs, guess what? The data is not going to integrate well, even though we're talking about the same thing. So that consistency also in the mission definition is also key. So when we were looking at the mission definition, where we were focused was building that common operational picture. Right, you got to build that joint combined operational picture to support freedom of maneuver in your AOR. So how do you gain and maintain contact on a target of interest in a congested and contested environment? And then the other piece was that's always been the multi-domain intelligence, surveillance, and reconnaissance picture. Well, when you're talking about multi-domain, you're talking about space, you're talking about air, you're talking about cyber, you're talking about maritime, you're talking about land. Well, it's no secret that the U.S. is very dependent on the space environment. What if that goes away? What if it's not as accessible or it's tasked to other things? Same thing with air. Well, if you're supporting the Marine Corps, they're on land in the environment. What is the Marine Corps' ability to contribute to that large common operational picture in a congested and contested environment? That was what we were tasked to kind of look at from a conceptual level, and what potential solutions would be out there from a capability gap that could solve that and fill that gap. You still have the task, right, to build that common operational picture. Okay. So when you look at mission engineering, there's three basic measures. You always have to have your measures anytime so you can prove, well, did you successfully solve what you were trying to solve? And you have the measures of performance, which are, your quantitative measures where you're looking down at the details of what's happening, but the traceability back up to your measures of effectiveness. And then overall, how does all that contribute to the overall strategy? Making sure that what you build, not only did you build it right, but you built the right thing. So you have to have that answer of why. And then, of course, the critical nature of the fidelity of what you're bringing, the linkage. Okay, where did that information come from that you're using? And then also, how was the data generated? Did you use it in a way that can be relied upon, or is there a significant amount of error in it? And the whole reason was you got to always be ready to answer the question of why or where did that come from, because it's going to be asked more and more. And having that traceability in your model was key. Okay. Other piece was being able to take all that data and then measure weigh the options. What we were looking at was, we know we needed to be able to sense and make sense of the environment. Should it be an unmanned system, an aircraft, or should it be a surface vessel? And based on the need for persistence, we weighed the different advantages, and it was determined that basically, in this case, and we'll walk through why in a little bit, the endurance, being out there for a period of time, as well as the ability to have more space for size, weight, power, available to you, so you could swap different sensors out, different boxes out to do different things and different capabilities within your environment, was more important than the speed, but the short duration of an aircraft. All right, so then growing your AI partner's knowledge is of course important. So what other information do you need to feed to the AI that you're using to make sure that it has the expertise so that you can query it and you can collaborate with it? So what we started looking at was, what were those commercially available maritime platforms, if you're looking at an unmanned surface vessel, that were out there, and also what are the sensors that are commonly used, whether you're looking at measuring the RF environment or you're looking optically. What do you have currently available that could be integrated and fielded in short order? So what we did was basically start collaborating and using AI as that collaboration partner So feeding it what we came up with our key system attributes, and saying, what else do you got out there? So what I can show you here is if you look at like endurance on vessel parameters, I knew that we needed what was the max endurance duration? How long could you stay out and operate in that environment? The AI came back and said, we want to know what your speed is as well, because the only way you're going to be able to determine how long is if you know what your fuel burn is. And the way you're going to determine your fuel burn is how fast you're going. So you've got to know those couple of things in order to determine how long you'll be out. Same thing with speed, and then we started looking at some other pieces as far as the optical capabilities. What's your pixel size at a certain range? How far out do you need to be? And then whether you wanted to do onboard processing or offboard processing. The advantage of onboard processing is limited data width to backhaul information. You can do it a lot smaller if you process the raw information on board. The risk, though, is what if somebody rolls up and grabs that vessel? Are you now doing classified information that you don't want to fall into enemy hands on the vessel? Is it better just to backhaul raw information and do processing somewhere else? So, all right. And then next, questions on that, and then what we have next is the video that kind of walks you through exactly how we did the mission thread analysis. But I'm happy to field any questions before we jump into that. All right.
In today's complex and rapidly evolving landscape, the Department of Defense faces a myriad of threats.
Y'all hear that okay?
To address these challenges, the DoD and the Marine Corps have embraced mission engineering as a critical framework to rapidly develop and deploy capabilities that maintain a competitive edge. To illustrate the power of mission engineering, Marine Corps Systems Command built a demonstration to showcase the use of a digital thread, connecting 4 different applications and actively sharing data from one source and compiling it with another. Powered by ANSYS Model Center, the demonstration seamlessly connected Cameo Systems model, 3 separate Excel files, and SDK. The digital thread enables high-fidelity trade study analysis and immediate mission validation using a mission engineering thread. In keeping with the Marine Corps' increased focus on robotic vehicles, an unmanned surface vessel, or USV, configured for the reconnaissance mission, was selected as the system of interest. Once current gaps were identified through the capability-based assessment, CBA, the team analyzed those mission gaps and designed a concept of operation simulation in STK. Leveraging a fabricated capability gap in the reconnaissance mission, the team designed a mission engineering thread around said gap, namely that current and planned future capabilities would not allow the Marine Corps to project persistent reconnaissance and surveillance capabilities to relevant ranges. This notional CBA also identified the operational requirement to develop an organic reconnaissance capability able to operate in the maritime domain. After analyzing the mission requirements, the team then decomposed more requirements within Cameo Systems modeling. These requirements were related to finding, fixing, and tracking targets in the littoral environment. Next, the team further developed capability requirements such as USVs shall be capable of autonomously detecting, tracking, and identifying maritime contacts of interest at ranges up to 8 kilometers in day or nighttime conditions. Following the mission engineering thread to identifying the key system attributes that would be related to target identification, resulting in a requirement dictating the focal plane pixel resolution shall be no less than 640 horizontal by 640 vertical pixels. Given that the analysis focused on the parameters of 5 different commercially available infrared sensors, focusing on the question, which sensor could satisfy the stringent operational target identification requirements and deliver an IR sensor able to meet the challenges of searching, detecting, and identifying high-value maritime targets in a congested and contested littoral environment. The next step was gathering data from multiple sources, focusing first on currently available commercial and military maritime infrared sensors. As you can see, relevant parameters such as pixel resolution, spectral band, and field of view are included in this spreadsheet. The data is crucial for the mission analysis, and the sensor data in this file was continually being updated on a disconnected spreadsheet, which was saved in a different shared network drive. The demonstration used Model Center to link to this spreadsheet and gain access to the needed dynamic data from the relevant cells. Importantly, as the parameters in the spreadsheet were changed, that new data was immediately available for integration, ensuring the study had the most up-to-date data for the mission analysis. The next data source needed was data on vessel performance. This data was in a separate file managed by another member of the team. Using Model Center, we were able to establish another active link with the file to obtain needed data using the vessel information with the sensor data highlighted earlier. Using Model Center, we were able to establish a data workflow, accessing multiple authoritative sources from Excel and Cameo Systems Modeler, and link the data together for a comprehensive exchange of data across multiple tools, conducting analysis and using those tools to display the results in a variety of different visualizations. Now that the analysis provided a clear answer on the best sensor, we leveraged Model Center to take the selected vessel sensor and generate a STK scenario file, allowing us to test the selected sensor in a mission environment using STK to determine if users could identify a target as a friend or a foe at mission-relevant ranges. This analysis aimed to illustrate how a digital thread could be used to conduct multivariable analysis across different tools and files. It was an example of how to use this approach to determine the most suitable infrared sensor for the mission, considering factors like pixel resolution and field of view, and how to validate the results within the context of a mission, providing increased confidence that the best sensor for the mission has been identified. This data-driven approach not only optimizes mission effectiveness, but also allows the Marine Corps to adapt to evolving technology and maintain the competitive edge required for victory on the battlefield of the future.
Okay. There's my briefing. All right. So effectively, the video walked you through better than me yammering at you could, kind of the nature of the scenario, and how we basically went back and forth with the different tool to make sure we, we're able to select the right solution. Now, the biggest piece in that demonstration was, where was AI? And again, wanted to use it as a collaboration partner. So it was pervasive throughout the foundation. There was lots of back and forth with the Google Gemini in this case, asking it different questions, making sure that the information that we were working with was accurate based on the authoritative sources that we had out there. And it was all done in collaboration with AI. So in conclusion, it is a big change. AI is a major change. We just have to use it, learn how to use it best. And this was a short use case just to spark ideas and opportunities that you may choose to take with you. It's mutual augmentation, right? That I'm using the AI to give me ideas, and I'm providing information back to it and seeing what it feeds back. The reason that I threw the cyborg in there was it makes you stronger, as opposed to the common analogy I've heard is, there's two phases again to using AI. One's like the centaur, half man, half horse, where there's very clear delineation between the horse and the man. Whereas the cyborg is the actual complete integration, the $6 million bionic man, where you actually have the synergistic effect of AI and the human together. So, questions? Who wants the box of harassment? No questions, really?
You randomly throw the box at somebody and they have.
All right. Thank you all very much. I appreciate the time.
All right, we have about 6 minutes before our next presenter. John.
Sure. Oh, yeah.
Could ask one question, John. Sure. Talk about going back and forth with AI.
Mhm.
What's your perception a planning perspective, we do that, is that real, a lot of work to do, a lot of additional work, is it, it's all new work, as a project manager, somebody came and said, how much time I've been able to spend dealing with AI tool? What would you give them for all?
So, well, there's two questions I would say on that, right? Is how much time did I save by asking the AI versus me going into the documents that I was asking questions about, or doing the research myself, pulling the information out, synthesizing or having to remember my percentage of time saved is tough to give you because I don't have the
No, I just pull on.
but you know, certainly hours of time savings from that. Being able to go in, ask the question, get the result, and even if it was looking at the result and then going to where it sourced the data from to make sure that it didn't hallucinate. Yeah, definitely. I did not. Hours would be the best way that I would have saved by not having to go in and research it myself.
Okay. Well, that's what I'm doing. We've been doing it too. Stuff that I do. Using AI, so as this research field, it seems in this particular thing, we have a lot more slop.
Yeah, okay. You still have to validate kind of what you're seeing, just like with product simulation. Also, I really
I came out the same thing. I went on wider. Well, they drag us around. Right.
Yeah.
I'm retired in Central Virginia. I'm not in
Okay.
I try to avoid going up there.
Hey, this is Andy. I'm just doing a mic check.
It's kind of brutal. You're moving there a number of years ago, swear, and it's going to be a pretty good tour.
That's probably working.
We're now there 20 plus years later.
Yeah.
Get the kids off to college and then what's going on?
We did about the same thing. We came out from California. We're going to do it myself.
All right, so yeah, we're in California.
Yeah. San Jose area.
San Diego. So military movement from the
our decision one kid, we couldn't find a good school system in California. I think we could.
Yeah.
My wife, she said she was from Southern Virginia, and that's not. That's not one.
Hi there. I don't know if you can hear me. I'm just doing a mic check.
So he's just spreading it out to yeah.
Andy, have you shared your screen yet?
No, I see something on the screen there. Can I put up what I have now?
Andy?
Oh,
Yeah, that's what I'm picking up.
Hello?
I deal with a lot of people from Philly. Literally,
That's why I don't save this. Because then he's gonna show.
okay.
Audio not going. It's okay. And can you hear me, Andy?
University of Maryland.
Gotta love it.
Okay.
Okay, so his audio is not good.
See, can you hear me now?
Yes, I can. Was
Is it coming in low? I set my gain a little low. Maybe that's why.
speak now?
Hello, testing. 1, 2, 3.
Yeah. I'll just try to talk a little louder. It's not loud.
Okay,
enough.
okay.
Should be good though.
Hold on. Okay, let me drink some water. I don't know if gain does anything, but yeah, let me see here. Oh, it says host disabled participant screen sharing. I can't seem to share anything.
Yeah, I got you.
Oh, okay, okay.
You're good now.
Okay. Thanks, Amir. Thanks.
No problem.
Yeah, let me pull this one up. Okay. Can you guys see this? Okay, I'm just going to go into presentation mode. All right. We looking good? Just
Yeah, we can hear you. Sorry, we're
oh.
muted. We're gonna be mute, but you're good to go. Everything's set.
Oh, okay, okay. Yeah, just double checking before I go ahead.
Yeah, I'm going to
Okay.
introduce.
I will
Right.
make sure. Because probably static is on.
Okay, good.
All
I'm
right,
gonna
I
assume.
have 12 o'clock, so we'll get ready to start with our next presenter. Our next presenter is Andy Tapia. He graduated from George Mason University with a BS in Systems Engineering. He has spent 5 years in the MBSE field, working as a systems engineer with SPEC Innovations. He supports the development and evolution of the cloud-based MBSE tool in Slate. Please welcome Andy.
All right, thank you. Thank you for introducing me there. Yep, my name is Andy, and I'm here with my presentation here, Enhancing Multilingual Collaboration Using AI in the Systems Engineering Lifecycle. So I'll just go on ahead here. I'll advance these slides. I think we've seen them. It covers what I've done. I graduated from George Mason, 5 years and counting. Very proud. All right, so for this this talk, this is kind of an overview of what I want to walk through. So just very briefly touching on the SE lifecycle here, then going into the challenges of multilingual collaboration. I'll walk into that. The newfound potential of AI, which leads us into some of the new use cases, such as AI-assisted translation. And then a case study of how we did it in Slate using a translation AI feature. And then I want to cover some benefits and drawbacks that I've seen, and then an opinion on a conclusion and a future outlook. So here we have, again, very briefly, the system engineering lifecycle. I'm sure many of you are familiar with it. And it's often represented by this classical V model here. So you see it's going through each of the phases: design, development, integration, testing, deployment, maintenance, and ultimately retirement. And I just want to get at how it's a structured and defined process that helps efficiently guide the production of systems out there. But the key points throughout this whole process is the fact that documentation and regular reporting are essential to this. It's important for teams and stakeholders to stay involved and informed throughout this whole process, whether they're technical or programmatic. And in order for them to be effective, there's a need to ensure that the information is clear and accurate for them when it's communicated. And you might assume that that we're all using the same language. That's how it is here. But with the rise of globalism, there's the presence of international or internationally distributed teams within organizations, maybe between organizations. And that when you have that allows for greater collaboration that's not limited by that physical location. So it could be between countries. And when you have that, the international teams and stakeholders that are involved can require multilingual collaboration. So some quick examples of maybe famous international related SE projects out there. Of course, you have the International Space Station, the Global Positioning System, and the World Wide Web that's out there. And all of these were developed with international cooperation, or at least cooperation after they were implemented and operated. And of course, you also have the users themselves that are global in nature, and they depend on the success of these systems within their day-to-day life. So then we come to the challenges of having multilingual collaboration in SC. This is not the first time it's actually been addressed in COSI, an international organization for system engineers. Had this topic come up back in 2016 during one of their conference papers in the UK. And borrowing from that paper, there was a couple of things that were highlighted. So first of all, the language barriers with the stakeholders. Having barriers can hamper the understanding of documentation, especially when it comes to the more technical topics without a knowledgeable or dedicated team, someone that doesn't have that language background, maybe. And with those barriers, of course, slower work and slower collaboration between the teams, especially when you're relying on traditional methods of translation. It can be time consuming, especially when you're dealing with large amounts of data, documentation, and all trying to maintain and preserve the intent of the original language. And another challenge, thirdly, is the risk of costly mistakes and misinterpretations. You're not having proper procedures, proper methods out there that could serve as a potential for unmanaged and unmitigated risk when you're going at these projects without one. And so, as many of you know, AI has recently come to the forefront of technology. Recently rose, and with its rise, it's given us some new use cases for many different domains out there. Chat AIs, the models right now, they're much more intelligent, and they can give more human-like responses to what you input to them. And that's thanks to the fact that they're trained on mountains and mountains of data. And the good thing is that data includes many different languages and topics that come straight from the internet and from texts and such. And thanks to that, AI can now currently support some language translation activities and services out there. From what I've seen, it's even capable of understanding instances of slang and some colloquial words. Some of the famous tools out there is ChatGPT, DeepL, Google Translate, and some more that are out there. But what if we can integrate them into our SE workflows? So here's our use case. What if we had AI-assisted SE documentation and reports? So here's where I think when you integrate that into our namely SE software tools and their workflows, I think that can increase the speed and accuracy of document translation. So especially when you have large documents that could be automatically parsed within the SE workflows. So for example, if you're baselining something, or if you're trying to get something out for review or keep someone informed, checking a policy, all kinds of things. When you do that, that frees up resources, that frees up time for maybe some users or some translator teams to focus more attention on the rougher edge cases out there. For example, some errors or some non-trivial cases, because languages are not always one-to-one. And that goes a long way towards preserving intent of the original language to make sure that's not lost. And an example I want to show is how we did it in InnoSlate. And we recently integrated ChatGPT features and capabilities into our tool. And so I'll go over that in a moment. And as a last note, I want to, it's a little broad, but I think that organizations should be capable of implementing their own AI models as they need to. And I'll revisit this back later on as to why that's important. Okay. And here's our case study of InnoSlate's translation AI feature. This debuted in version 4.11 fairly recently. And what it does is that it automates the process of translating documentation on an entity by entity basis. I think right now what I've seen is that it's capable of translating across up to 16 supported languages out there. In our tool, it's available within Documents View, Compilation View, and Test Suite documents. But what that essentially means is that it simplifies the translation process for when you're dealing with project documentation, when you're handling requirements and the test cases out there, so verification, validation activities, all of which are vital to the SE process. And so here's the first example I want to show of our case study. This is going to be how it's done in a requirements document. I took these images from our InnoSlate Help Center. It's available for anyone to look through. So here on the left side, you can see rows and rows of requirements. Each row is an entity. And when you're looking to translate a whole document, you can go look above. You'll see a tab. One of them is called More. And assuming you have the AI features enabled, you can go to the very bottom and press the translate option, which will kick off the automatic translation process. So when you press that button, that starts up a modal, this configuration menu here. Prompts you for a language of what you would like to translate to. And what it's doing essentially is that it's creating a new instance, a copy of the document you have now, and we'll create a new one based on the language that you want. And so you can define the name, number, and description you would want for that. And as you do that and fill that out, you can click on next, and then you'll see a progress bar showing you how we are translating it on entity by entity basis until it's complete. And once it's complete, you can navigate to the translated document, and you can see it here. So the original document has been translated, and then the user is free to inspect it, to review it, just to make sure everything looks right and nothing's lost from there. And here's a second example of an alternative way you can do it. This is in Documents view. You can still do the previous method in Documents view, but this is just another way of going about using translation AI. So here I put in a Spanish B2 passage. And for those that don't know, B2 is essentially upper intermediate level of Spanish fluency. So I just put in this passage here. And when I go into the entity, to the text field, I can go into the toolbar. And again, assuming you have AI features enabled, you can click on the AI text tools button there, and you'll see two options, translating the current block, and that a block refers to the paragraph. Each paragraph is now its own block, or translating every block, and that's what I chose there. I forgot to include it, but as soon as you click translate every block, which is what I did, it opens up just another drop down of what language you would want. Here I chose English, so I went from Spanish to English this time. And once I click the option, it just automatically flips everything to the language that you set. So there's no modal here, and it just goes straight away. And then you can inspect it, see if everything lines up or it looks understandable. And then here I'm revisiting what I mentioned before about organizations needing the flexibility to be able to use the models they prefer, or maybe even their own models. So within the tool, the InnoSlate tool, admin users can set controls for the organizations that they're a part of. Maybe you want to use a different type of model. You can put in your API keys for that. And especially when you're dealing with perhaps sensitive information, for example, CUI, that's where this would come into play. Or if you're using your own models for that same purpose, that helps with that. And there's also some additional controls for your users. For example, token limits, whether you want to use image AI or just not have the features enabled at this time at certain times to keep costs down and things like that. So we have that available. And then this is just a close-up of the drop-down of the list of things that are out there. Right now, there are some different ChatGPT models available, but you can still use your own. You can still use your own. And okay, and so having AI enhanced collaboration for multilingual teams in SE, I think this really addresses the challenges that were brought up way back in 2016 or 2016. So that can help resolve issues when you have multilingual or globally distributed stakeholders and the teams. They can more easily work in their preferred languages. They can be more confident about what they're doing and making sure that everyone can understand the work that's being done. You can have faster collaboration in SE workflows. You can process the engineering documentation much more quickly between the teams, or at least understand the documentation much better. And then, of course, having fewer mistakes and miscommunications. And this can be buffed even more if translation teams leverage the AI assistants available to help them preserve that intent, that original intent, and more quickly resolve some of the language issues that might come up to make sure everything's looking good. And so overall, I think the benefits of having these types of tools in SE is number one, of course, higher efficiency. Having this AI translation drives the costs down, speeds the translation times up, especially for when you're dealing with large amounts of documentation. And of course, naturally, more productive collaboration. The users will be more effective and can have more inclusive communication across teams, within teams, and the stakeholders as well. There's also reduced risks. The miscommunications are minimized. Some of the errors, translations are patched up, so that helps reduce potential disruptions that can come up just because of language issues. So that can be mitigated and managed. And then, of course, having increased translation accuracy. So again, combining them with translation teams, the translation quality can be improved even more if you have one existing. And then, of course, however, there are some drawbacks to the tools. From what I've seen, I think these are important to consider. So these models are very intelligent, but there's still some difficulties. So from what I've seen, there's still some difficulties when it comes to translating certain complex terms and maybe even industry jargon that comes up. So certain acronyms, words, and phrases that may be highly technical or specialized, they may not be easily translated. Sorry, I lost my train of thought. Yeah, they might require also more context. So maybe the machine needs just a little bit of a rope. You might need to throw some rope at it so then it knows what you're talking about. Just can't take it from the surface level. But there could be some difficulties there, as well as this next topic here, translating to the more uncommon or niche languages that are out there. By virtue of being uncommon, naturally you can imply that you have less content to train on in the first place, and you should be a little bit more careful because that could lead to underperforming translations out there. So you just want to be careful of that, maybe extra checks if you're dealing with something like that. And then lastly, you have its usage in certain specialized domains, specifically the ones that SE can overlap with. So for example, healthcare, law, and research, you might find some unique problems that need to be resolved there. For example, if you're trying to preserve IP, address privacy and safety concerns, and maybe some ethical considerations even. And some of this could be mitigated by having a closed loop AI model, but that might not be all what you need to do. So it's just something to consider as well when you're using these tools. Okay, and then this is what I think for my conclusion and future outlook. I think that ChatGPT and similar AI models that are out there will continue to rapidly improve, likely on an exponential level scale. when it first came out, it seemingly came out of nowhere, at least for me. So I feel like that will very likely continue. And as they do, they'll just continue to improve and maybe even surpass their own capabilities as they get more data, ensuring that at least we'll have equal or greater effectiveness in the future. But I think one important point to make is that human languages are not always static. It's always evolving, and we're always creating new terms, new phrases, and that just might come alongside technological innovation. We're coming up with new things. For example, electricity was not a concept that was known at one point until it was invented. So I expect that kind of behavior to continue. So maybe we'll need to keep feeding the machine or tell it more about what we're doing to keep it up to date. And then as a last point, I think that in the most critical fields or even the most critical decision points that you encounter, it should still remain vital and essential that humans are the ones to review the translations, to number one, ensure the accuracy of it all, and then number two, the accountability. And it's very important that someone is responsible and also able to explain why decisions were made and that kind of thing at those points. And then with that, I think I will get off the stage. I'd like to thank the event organizers here at MBSE-CON for letting me be here and speaking with all of you today, as well as my colleagues, my president, company president, Dr. Stephen Dam, Mirabari, I think he's here, Dominic Galarza. They were the ones that chiefly implemented AI features within InnoSlate in this recent cycle. So thanks to them and to all of you for being here. Then I think I'll open the floor. I think I only had 20 minutes, a little over. Okay.
Okay, any questions for Andy? Yes, there's a question. Let me get you the box.
The box. Oh, was it at a different point in my presentation?
No, this question is 411's been out in the wild for a bit. Do you have any field experience anecdotes from people that are using it in Translate?
What I'm understanding, I'm reading it back to you to make sure I understand. It's a little fuzzy from my audio. You're saying if I have any experience with somebody using this feature already, or just my work experience?
So do you have people that have been actually using it and giving you any feedback?
I don't have any stories to share yet. I think when we implemented this earlier in the year, or maybe towards the end of last year, so I don't have any instances to share with you on that so far.
All right, any other questions? Okay, thanks, Andy.
Oh, okay. All right. Thank you very much.
So now we can